All right. So, just like with all inverse trig functions, you can find the inverse by switching the input and the output. So, when we were finding them algebraically before, we would just switch the x and y and solve for y. So, a similar thing happens with the inverse trig functions. So, for the original trig function, you put an angle in, and what comes out is like the sine of that angle or the tangent of that angle. For the inverse trig functions, you put a value in, and what comes out is the angle that has that sine or the angle that has that cosine, whatever. So there are two notations for inverse trig functions, and this is the one you probably remember maybe from geometry. I'm not sure. I don't think you spent a lot of time in Algebra 2 talking about inverse trig functions. This might be a new one, but they mean the exact same thing, and they're both read as the arc sine. You can say the inverse sine, it's fine, but technically it's supposed to be read as the arc sine of x. All right, so on example 1, we're going to take this statement and we're going to write it an equivalent statement using the arc sine notation. So we know that the sine of pi over 6 is 1/2. So what that means is that the arc sine of 1/2 is pi over 6, because pi over 6 has a sine of 1/2. All right, you guys are going to need your unit circles, so you might grab those real quick. We're going to use those quite a bit this whole week, actually. We may recreate it again one day this week, just so make sure you haven't forgotten how to do it. All right, so on part B of this, we're going to do the opposite. It's written as an arc cosine statement. We're going to write it as a cosine statement, and then we're actually going to find the value of x. And so what we know is that the arc cosine of x is 1/2. So that means that the cosine, not 1/2, sorry, pi over 2. The cosine of pi over 2 is x. Right, then you guys can look at your unit circle, go to the angle pi over 2, and then when we're looking at the unit circle, the cosine of the angle, is that going to be the x or the y coordinate? The x. And so at pi over 2, what is the x value? 0. Good job. All right, now I've been teaching inverse trig functions for many, many years, and I always have a really hard time articulating this next part, so just hang in there. This is a little different than what I usually do, but it's almost identical. But if you guys remember back when we did inverses in unit, I can't remember 2 or 3, for a function to have an inverse function, do you remember what it had to be or what it had to pass? It's been a little while. It had to pass the horizontal line test. It had to be a one-to-one function. Which means there's one x for each y and one y for each x. But what we would double check is that it passes the horizontal line test. Now, all the trig functions are periodic or cyclic, and they just repeat this pattern over and over and over again. So they would never pass a horizontal line test if you didn't restrict the domain. And so what you do is you take the sine function and you restrict the domain to only this much. So it does pass the horizontal line test. And the new domain that you're using is where the x's are from negative pi over 2 to pi over 2. All right, and then for the cosine, obviously the whole cosine function is not one-to-one. So what we do is restrict the domain to this much. We can't do it the same way that we did it with the sine, because if you went from negative pi over 2 to pi over 2, it wouldn't be one-to-one. It wouldn't pass the horizontal line test. So it has to be different. So we go from 0 to pi for cosine. All right, and then for tangent, I don't have the graph on here, so I was trying to not use a ton of paper. But the tangent, you're going to use that one period of the tangent where the domain is from negative pi over 2 to pi over 2. So if you guys remember, whenever you have inverse functions, their domain and range is switched. So we restricted the domain for sine to negative pi over 2 to pi over 2. So that is the range of the arc cosine. The arc sine, sorry. So the domain and range are switched. All right. Then for the original cosine graph, the restricted domain was from 0 to pi. So that is the range of the arc cosine. And then the restricted domain from tangent becomes the range for the arc tangent. Okay. Now, you don't have to remember the whys. I always want to explain the why that works, why it is the way it is for people, because some people really need to know. But if you can just remember that whenever you're doing the arc sine, the angles that you get must come from quadrant 1 and quadrant 4. You can't give an angle in any other quadrant for the arc sine. When you do the arc cosine, the angles must come from quadrant 1 and quadrant 2. And then arc tangent angles must come from quadrant 1 and quadrant 4. All right. Now, if you guys look at your unit circle, your quadrant 4 angles aren't between negative pi over 2 and pi over 2. They're between 3 pi over 2 and pi. And so we do have to alter a little bit from what is on the unit circle. So for example, you don't have to draw this, but I just want to do it real quick. If we had this angle, that's 7 pi over 4. 7 pi over 4 is this. Right? 7 pi over 4 is not in that range between negative pi over 2 and pi over 2. However, negative pi over 4 has the same terminal side. They are not the same angle. This one obviously is bigger and in a different direction, but they have the same sign and they have the same tangent. And so all you have to do is find the angle from the unit circle. If a 4 is the denominator, it's negative pi over 4 is the angle you use. If 3 is the denominator, it's negative pi over 3. 6 is the denominator is negative pi over 6. So I think you'll get used to it. It's just going to take a minute because we haven't done that a ton this year. Okay, so let's do some examples. On example 2, we want to find the arc cosine of negative square root of 2 over 2. There are multiple angles that have that cosine, but we have to choose the one that is in quadrant 2. So if you're looking at your unit circle, look over at quadrant 2, find the angle that the cosine is negative square root of 2 over 2, or the x coordinate is negative square root of 2 over 2. What do y'all think? That's the arc cosine. That's the angle in the correct quadrant that has that cosine. All right, for B, we need to find the arc sine of negative square root of 3 over 2. So again, there's multiple angles that have that sign. We are going to have to pick the one in quadrant 4. Oops, sign's over here. In quadrant 4. And we cannot use the angle that's on our unit circle. So just looking at your unit circle, which angle has that sign? Or which angle has that y coordinate? All right, so 5 pi over 3 does not fall between these two angles. So all you have to do is look at the denominator, and it's negative pi over 3. They're called coterminal angles. They have the same sign. So this angle and this angle both have a sign that is this. Different angles, same sign. All right, and then tangent. When it's positive, it's a lot easier. You don't have to think as much. If it's positive, it's just going to come from quadrant 1. And so we're looking in quadrant 1. We're doing the arc tangent of the square root of 3. So, well, tangent is kind of difficult, though. So we're looking at the unit circle. We want to figure out which angle we could do the y-coordinate and multiply by the reciprocal of the x-coordinate and get the square root of 3. What do y'all think? You would want to choose one where the square root of 3 is in the numerator on the y. Yeah. All right, so I know that takes a little bit getting used to. We're going to practice it some more on these next examples too. All right, so on the 4th free response question on the AP test, you're probably going to have an equation like one of these 3. And they look weird. Like if we hadn't practiced this and you were just taking a test and you saw that on it, it's kind of hard to know where to start. So we're going to practice it a ton. So what we're going to do first is the side that has an X, you're just going to leave it for now. And then the other side, we can figure out what it is using the unit circle. So we're looking for an angle on that unit circle whose tangent is 1. Because it's positive, it's going to come from quadrant 1. So that's something I hope you have memorized pretty soon, that the tangent of pi over 4 is 1. Because you think about the slope at that angle is going to be 1. All right, now what we're going to do is what we did back here on B. So we had an arc cosine equation that we changed it to a cosine equation. And that's what we're going to do here. We have an arc sine equation that we're going to change to a sine equation. So this means that the sine of pi over 4 is x. So what we can do is look at our unit circle. What is the sine of pi over 4? Square root of 2 over 2. And that's it. So it's not terrible, but if you had never seen it before, it's kind of hard to know where to start. Now they do get a little more complicated, like B and C. I don't think it's going to get any more complicated than C. I don't think they'll add anything else to it. Let's look at B. So we're going to start off the same way. The side that has the X, we're going to leave it exactly like it is. And then the other side, we're going to figure out what the arc sine, the arc cosine of 1/2 is, or what angle has a cosine of 1/2. What do y'all think? Pi over 3. Good. All right. So we're not quite ready to do what we did here because we have this 2 in the front. So what do you think you do with it? Divide by it. Good. All right, so somewhere in your head, I need you to be able to divide a fraction by 2 or take half of a fraction. Either way, dividing by 2 and taking half mean the same thing. So in your head, you might just be able to think, okay, half of a third is a 6, so this is pi over 6. Or you might go over to this side and multiply pi over 3 by 1/2. Either way, I hope that you can do that without stressing out too much. All right, so now we're ready to write this arc sine equation as a sine equation, where the sine of pi over 6 is x. All right, so all we need to do is look at our unit circle and figure out what the sine of pi over 6 is, or maybe just use it in your brain, 1/2. And so we can check these if you wanted to. We can take that 1/2 and put it in here, and you should get the same thing on both sides of the equation. So you should end up getting guess you end up getting pi over 3 equals pi over 3 in the end. All right, one more. So this one, same thing. We're going to leave the left side alone, the side that has the x. Figure out what the arc sine of negative square root of 3 over 2 is. Good job. So it's going to be in quadrant 4 only. And that angle is actually 5 pi over 3 on your unit circle, but that correlates to negative pi over 3. All right, go ahead and divide by that 2 again. Right, and then this is going to be slightly different. When we write this as a tangent equation, instead of just equaling x here, it's going to equal pi x. And then we can figure out what the tangent of negative pi over 6 is, or it's going to be the same as the tangent of 11 pi over 6. So we take the y and multiply it by the reciprocal of the x. It's going to be negative 1 over the square root of 3. So that's what pi x is. So what do we do to find x? Divide by pi. So when you divide by pi, you can think of it different ways. I think probably the easiest thing for me to think when I'm dividing by pi, I'm multiplying by the reciprocal of pi. So anytime you divide by a number or a fraction or anything, you are multiplying by the reciprocal. And that helps me visualize like what happens with it. All right, so look at those three. You're going to see them again. We'll practice them a lot. Probably not as much as we practice the sine curve, the A, B, C, D, all that stuff, but we will definitely keep on keeping on with these. All right, so let's look at example 4 and 5. So example 4, we have this theta is in standard position and the terminal ray intersects the unit circle at point P. And the coordinates of point P are x, y. And then we have Q, R, and S that are the results of doing a bunch of reflections. So let's figure out the ordered pairs at each of those. So Q occurs when P is reflected across the y-axis. So what are the coordinates of Q? Negative x, y. Very good. All right, and then R, we're reflecting across the origin. So it would be negative x and negative y. And then S, we're reflecting across the x-axis. All right, and so this question is asking us for each of the following expressions, determine the label point determine which label point intersects the terminal ray at those angles. All right, so whenever we're doing the inverse cosine of something, in this case, well, in all cases, it needs to come from quadrants 1 or 2. So our answers for this one is going to be P or Q. Right? And then for inverse sine of something and inverse tangent of something, those are going to come from quadrants 1 or 4. So in this case, it's going to be P or S. So we're never going to use R. So you can just mark it out. Don't answer R for any of these. All right. So on A, we want to know which point is going to be used whenever we are doing the arc cosine of x. So what we do is we just look and see which point the x is positive, so that's going to be point P. Oh, wait. Oh, sorry, I'm looking at the wrong one. Then for B, the arc sine of negative y. So we're just like to see which point has the negative y. That's going to be yes. Good. All right, so you guys try C and D on your own. D might be a little tricky. All right, so for Q, we're looking for the negative x coordinate. And then for D, we want to be able to divide the y and the x and get a negative. Okay, now you guys know I use Brian Passwater stuff, and I couldn't find what I needed to do this problem. I made up example 5 on my own. And so we're going to have to redraw theta. So theta is not going to be the theta that's drawn. I just copied and pasted the one above. Theta is actually going to go here. That's theta. It goes to Q instead of to P. And that's the point that's called xy. That does not mean that the x coordinate is positive. It just means we are calling the x coordinate x. This is going to feel kind of weird. I'm going to take that, I'm going to reflect it on the y-axis. So what should my p coordinates be? It's the opposite of x, y. And I'm not saying the x coordinate is negative there. It's just going to be opposite of what we are calling x. All right, and then for s, the x is going to be opposite and the y is going to be opposite from what we're calling x and y. And then for r, the y, the x will be the same coordinate as it is on Q, the y will be opposite. All right, we have the same rules for what we give for inverse cosine of something. That has to come from quadrant 1 or 2, so that's either going to be P or Q. And then the arc sine and arctangent are going to come from quadrants 1 and 4, so that's going to be P or S. Okay, so when I do the figuring out which point is we're going to use for the inverse cosine of negative x, we're just looking for negative x. In this case, it is P. And then the arc sine of y, we're going to look for the positive y, which is also P. And then the arc tangent, we need to be able to divide the y and the x and get a positive. So what do y'all think? That's going to be S. Good. What do you guys think about D? Q. All right. So I know that's weird. But just don't think of them as positive and negative. Think of them as opposite of the original.